Well, Matrix, welcome back. What we're going to be looking at in this lesson is the present value annuity formula, but it involves what we call loans, where money is borrowed. Okay, look at that, the word borrowed. You borrow money from bank and you have to pay back with interest. Now, let's just revise our grade 11 work. What amounts can be borrowed if the loan is to be paid back by amount of 10,000 Rand in 2 years' time at an interest rate of 10% per annum, compounded half yearly? Okay, so the thing is, we're dealing with one amount. Okay, it's going to be paid off in 2 years. So if I draw a little timeline, just to illustrate what's going on. Okay, there's a whole lot of maths here that you did in previous years. But if we take, for example, a timeline, we're going to go over a period of 2 years. Okay, and a certain amount is going to be borrowed at here. We call it the present value. It's borrowed and it's replaced by an accumulated or final amount here of 10,000 over a 2-year period. But remember, the interest rate is 10%, which we divide by 100. Always 10 divided by 100 is 0.10. But the thing is, it's compounded half yearly. Now, if you remember that, if your interest is 10% for the year and you divide by 2, you're then talking of half years. That's every single 6 months. 6 months, 6 months, and so we go on. Okay, so in a period of 2 years, you're going to have basically 1, 2, 3, 4 6-month periods. Think about it. 6 months plus 6 months gives you 12 months, which is a year. Then you have another 12 months, which is another year added on. But that's 6 months and 6 months. So it's 6 multiplied, or 6 plus 6 plus 6 plus 6, which is 6 times 4, which is 24 months. But a 6-month period is 1 half year. So a half year is basically that piece, okay, which is made up of 6 months. So how many half years in a year? Well, there's 2 half years in a year, okay, and how many half years in 2 years? Well, that must be 4. So if you think about this carefully, we're going to have, for the period of 2 years, we're going to have, the time period would then be, if you think about it, would be 2 years, which it is, they said 2 years, multiplied by 2 half years. Okay, and that will give you then, of course, 4 half years. Okay, so the time period is 4 half years. We invest, or we pay a certain amount, we borrow a certain amount here, let's rather say it's a loan, and we repay this. But remember, this is a higher amount to what you borrowed. So we want to know what the lesser amount is there. So how did we do this in earlier years? Okay, let's just go back and read the question. What amount can be borrowed? That's P. If the loan is to be repaid by an amount of 10,000 in 2 years' time at an interest rate of 10%, half yearly. Okay, so let's write down what we know. Okay, A is going to be 10,000. That's the accumulated amount. That's the loan that you're going to pay off in 2 years' time. The present value is, you don't know that. Okay, you don't know what you borrowed. Okay, the amount borrowed. The I is 10% divided by 2, okay, which is 0.05, if you work that out. And N here we've got here is 2 years times 2 half years. There's a half year, that's every single 6 months, and there's 4 half year periods in the 2-year period. Okay, and then if we use our compound formula, which says A is equal to P plus 1, P into 1 plus I to the N, we know that A is 10,000, the P is unknown, but it's 1 plus the 0.05 to the 4. Okay, 4 half years and 0.05. Okay, then if we work that out, what do we get? We get 10,000 is P. This 1 plus 0.5 is clearly 1.05 to the exponent 4. Okay, now how do we solve for P? Well, clearly what I could do, if you think about this, is if I divide both sides by 1.05 to the exponent 4. I do it on the left as well. the aim, of course, is now to be able to free you to get P. So what would this be? Now, I want you to watch this carefully. Those cancel, which is great. You've got 10,000 divided by 1,05 to the 4. Now, another way of looking at this, you could work it out. I mean, you could easily go and work out what P is. In fact, if you worked it out, it would come to 8227,02. You simply plug it in the calculator, and there you go. You've got your amount that you borrowed. But another way to look at this, I want to just go back to exponents because I want to show you a shorter way of dealing with this. It's really revision of earlier years. Do you remember that if you had a, for example, ax to the minus n, what you could do, remember that's a multiplied by that, you could through exponents go like this. In other words, bring that negative exponent underneath the expression x to the negative and just migrate to the bottom there. Now reverse this. So a over x to the positive exponent n can be reversed as ax to the minus n. Now if you do the same here, this is a, and this will be x to the n. Okay, now bring it up. So you've got 10,000 into 1,05 to the negative 4. Okay, now that's exactly the same as this, and if you simply use your calculator, you go 1,000, open bracket, 1,05, close bracket, raise it to the exponent negative 4. You get a lower amount, a lesser amount, and this is going to be a big feature here. Remember, that is A. Okay, now what does this tell me? Well, it tells me that I borrowed money, and I borrowed a total over here of 8,227 Rand and 2 cents. And because of interest, this interest, I owe 10,000 after 2 years. So I borrowed 8,227, but I pay back, 10,000 is because of interest. Not a good idea. Better to pay cash. But now, people, I want you to look at this. If you look at this little expression here, you've got a new formula. You've got P, the original amount that you borrowed, is A, which is that thing, into 1 plus the interest, which was 1 plus 0,05, to the exponent. Now look at that exponent. It's negative. So there's two formulas that we can use. So this is used when you're given the A, okay, and you want to find P, which is, in this case, it says what amount must be borrowed. You want to find P if you're given an amount in the future. Okay, which is great. So what we do is we've got this 10,000 Rand in the future, and what do we want to do? We want to get our original amount. So we put the 10,000 in, 1 plus the half-yearly interest rate to the negative 4 half years. That is the A. That's given in the future. On the timeline, it appears over there, and we want to know what its original value was there. In other words, what did you borrow? Okay, you see, so the two formulas that we then have is, the one is if you've got this normal grade 10 and 11 one, this is you given the value of a loan and how much will you owe in the future. You've got to find A. Okay, you given the P, and you want to find what is the amount that it's going to, in other words, the amount with interest that you're going to pay off. So you start off with 10, or say 8,000. What are you going to pay in the future if you're going to be charged interest? Okay. Now this is a situation with one payment. Now people, that's okay. In grade 10 and 11, that was fine to deal with it. But the real world does not work like that. And what I want to do is I want to focus on a second example where we involve more than one payment. So stay with us, and then we're going to go into a whole lot of payments and see what happens then. So stay with us. We're going to do a second example. Okay, Matrix, let's look at a second example. Suppose that a loan, is repaid by means of a payment of 1,000 Rand. Hold on to that. 1 month after the loan was granted, and one further payment of 1,000 Rand 1 month after the first payment of 1,000. Okay, calculate the amount borrowed. So there we want to find P if the interest rate is 6% per annum compounded monthly. So let's just analyze this on a little bit of a timeline. Okay, so if I draw a timeline, have a look here. We're going to go, so we start off, okay, now what happens here is we borrow money. Okay, we call that the present value. We borrow money here. And 1 month later, a payment of 1,000 Rand is made. A month after this, another payment of 1,000 Rand is made. Okay, now listen carefully. Let's just go back and have a look here. Suppose that a loan is repaid by means of 1,000 Rand 1 month after the granting of the loan. Okay, and 1,000 Rand after that. Calculate the amount borrowed. The interest is 6%. Okay, so it's 0.06 divided by 12, which of course is your monthly interest rate. It's 6% per year. Divided by 12 gives you your what we call the monthly interest rate, and they want to know how much was borrowed. Okay, now this is a bit tricky. We've got our interest rate here. Now, the trick with this is what we want to do is we want to know what the value of this amount is back there. Okay, so what we could call this is the accumulated or the loan 1, and this we can call loan 2. And so what we're going to do is we're going to bring this back. Now from grade 11 days, watch this. What you would do is you'd say, well, if we use the little formula, I'm going to divide this into 2 parts, this P. The first part could be a P1, which corresponds to A1, and the other one is a P2. Now watch this. Your first part of the loan, so in other words, remember the loan here is made up of is repaid over 2 months. Okay, now let's reflect back and let's just take this loan payment A1. It's going to be A1 into 1 plus 0.06 over 12, and we're taking off 1 month's interest. Okay, that's the formula. Remember, if you go back, it's P1. This is A1 into 1 plus 0.6 over 12 to the negative 1. Okay, now if you work this out, watch this. This is 995,02. That is the value of P1 there. Okay, remember it's lesser. Okay, it's a lower amount. So it's like you borrowed 995 Rand and after a month you pay back 1,000. What about A2? Let's have a look at A2 here. Well, the amount borrowed, if corresponding to A2, would be the amount at A2. All grade 11 and 10 stuff this. 0.06 over 12 to the negative 2, because you're going back 2 months. It's 2. Remember, this is, by the way, not years. This is a month. We're going in 2 months, not years. Okay, so it's 2 months, 1 month here. Now, if you work this out, the value of the loan P2 would be 990,07. Okay, now that's great. Okay, that's no problem there. Now, the problem is a lump sum was borrowed, but really, what you really did is you borrowed P1, which was 995, and paid it off with this one. But you also borrowed P2, which was 990,07, and you repaying that with this 1,000 Rand there. So what is the actual loan made up of, if you think about it? This P over here is really the sum of those 2 loans. That's the total amount borrowed. So the P is actually, if you think about it, it's P1 plus P2. So what we do is we say the P is this guy, which is that 1,000 there, the one at T1 there, 0.06 over 12 to the negative 1, that's that 995, and then we're adding to this the other loan, which is a T2, which its present value, or what you borrowed, was 1,000 into 1 plus 0.06 over 12 to the negative 2. So, of course, if you add up all of those 2, which is really the sum of these 2 guys, if you add them up, you're going to get 1985,10. So the total money borrowed was 1,985, and you repay 2,000 Rand over 2 payments with all the interest added in. So in other words, P1 is repaid by this 1,000 with the interest. P2 is repaid by this 1,000 in the future. But if you look at P1 and P2 and you add them, that total amount borrowed is repaid by means of these 2 payments. But this is fine with 2 payments. But of course, it's going to get a bit challenging if you have to look at it if there are 20 or 30 of those. So we need to explore this a bit. So this is the basics. It's really grade 11, but we need to take this a little bit further. Okay, so guys, what I want you to do, just before we move on, I want you to do a practice example that involves these kind of payments. Okay, we've got, and I want you to try it on your own just to work with this, and then we'll take it further. So here's the practice example. Try it, and we'll be back for in the next part of this lesson to actually look at a formula that's going to help you deal with a whole lot of payments. Okay, try it. We're going to talk through it again, and let's see how we go.